Here's guidance for quiz 2. I'm going to repeat what I've been saying and will for some time because repetition is the key to many things, including logic. Remember to try this on your own first. Don't just use the video to get the answers. That will not prove to help you out in the long run. And like with much of life, it's about the long run, not the short run. Short run is easy, long run is harder, but that's part of what schooling, education, and life is about. So here we go. In the book, try exercise 10 on page 35. What I have here in 1A and B is parallel almost exactly to that. The reasoning there is sort of explained a little bit. Remember, answers are always in the back of the book too for you to try. This is a good one to exercise your minds with. And I'll briefly outline the answers. So if for the first one, if he rolls 4 2s, what's the chances that that occurs? You don't have to calculate this. What's the chance of getting 1 2 when you roll a die? Well, there's one possibility for 2 because there's one face that has a 2, and then there's 6 possible outcomes: 1 2 3 4 5 6. Remember, probabilities are possibilities divided by possibilities. They're weights, as it were. This out of that. 1 divided by 6 is one way of getting 2 out of 6 possible outcomes. So there's one possibility over divided by out of 6 possibilities. So 1 out of 6, 1 divided by 6. That's all the fraction represents. One possibility divided by the 6 total. Times, since they're independent, right? Each roll of the 2, you can do it one time, pick it up, roll it again, or you can have 4 die in your hand and roll it all at once. They're considered to be independent of one another, meaning no memory, no relation. So you can, that allows for multiplication. You can multiply that by the second one, which is 1 6. That's the other way of getting another 2 times 1 6 times 1 6. You don't have to calculate this out. The course is not about calculation, it's about concept. So this formula is enough. For B, this looks like it's plausible, but actually this is the inverse gambler's fallacy. Why inverse? Well, try it out in the book first. The fallacy means it's a mistake because what it violates, once again, is the assumption of independence. It's inverse because it goes in the opposite way. Try it out. If you get it, great. If not, don't worry about it. For 2, 3, and 4, these are all straight out of the lecture. It's basically, the question is, have you read it carefully? And in addition, in the lecture, I have a lot of these things highlighted in a different color to indicate more important concepts. So you go back to the lecture for this quiz and fill in each of these. If you're getting this wrong, that means you're not doing the most basic of things for the course, which is some careful reading. Yeah? So do that. 3 is the last one. 5 is the tricky one. And remember, for some of you who still might be asking this question, the 3 points, 2 points, that's for me, not for you. Each of the quizzes and homeworks are worth 2 points possible. So you need at least 75% right total to get the 2 points. I allocate according to what you got here, whether you got at least 75% correct. So the 3 points, 1 point, 2 point, 3 points, that's for me, not you. Don't worry about that. So for the first one, all of this is, by the way, covered in the lecture. I just use the different versions. You should go back and read that again, try to understand. Let me give you a quick summary here. So for the first one, if you commit the gambler's fallacy, that's like challenging the reasoning because you're saying that the inference, the reasoning that you make is incorrect. You assume that the game is fair. You then commit the gambler's fallacy. That means you mistakenly thought that the wheel has a memory, which it doesn't. That violates the assumption of independence, which is like challenging the reasoning. The next one, when you see a run of 12 blacks and infer that the wheel is biased, so you're going to go the opposite way and think it's red, you don't make a mistake in reasoning. You go back and you challenge the premises, in particular the assumption that the wheel is fair. And of that, remember, fairness requires 2 parts, that it's unbiased and independent. You think that the wheel now is biased. So you're challenging your initial assumption that the wheel was unbiased because the chances that you get 12 blacks is very low. I do that calculation. I step you through it in the lecture, so you take a look at that. Okay, just get this in, get the 2 points. Remember to keep the pace, move on. That's the key to the course.